National Electrical Code Section 450.13c addresses the separation of conductors from different systems. It explicitly states that conductors of different systems shall not occupy the same equipment, enclosure, or raceway. This regulation is in place to prevent potential hazards and ensure the safe operation of electrical systems. In this scenario described, running the secondary conductors of a 480/208 volt transformer through the 480 volt panel to the 120/208 volt panel would violate this code requirement. The 480 volt conductors and the 120/208 volt conductors belong to different systems, and therefore they cannot share the same electrical panel. National Electrical Code Section 450.13d provides an exception to the rule outlined in 450.13c. It states that conductors of different systems may be installed in a common raceway only where separated by a continuous and firmly fixed barrier. This means that if the 480 volt conductors and the 120/208 volt conductors were to be installed in the same raceway, a physical barrier would be required to separate them. The barrier must be continuous, meaning it must extend the entire length of the raceway, and it must be firmly fixed, meaning it must be securely attached to the raceway. In the specific case of running the conductors through the 480 volt panel, the panel itself does not qualify as a suitable barrier. The 480 volt panel is not designed to prevent the conductors from coming into contact with each other. It is primarily designed to house and protect circuit breakers or fuses that provide overcurrent protection for the 480 volt system. The internal components of the panel, such as the busbars and wiring, are not insulated or arranged in a way that would prevent accidental contact between conductors of different voltage levels. The primary concern with running conductors of different voltage levels in the same enclosure without a proper barrier is the risk of electrical faults. If the insulation on the conductors were to fail, it could result in a short circuit between the 480 volt system and the 120/208 volt system. This could cause a significant amount of current to flow, potentially damaging equipment, causing a fire, or even posing a safety hazard to personnel. Furthermore, the mixing of conductors from different systems can make it difficult to troubleshoot and maintain the electrical system. If a problem were to occur, it could be challenging to determine which system is affected and to isolate the fault. This could lead to extended downtime and increased repair costs. It is essential to maintain a clear separation between electrical systems to ensure the safety and reliability of the electrical installation. The best approach is to run the 120/208 volt secondary conductors in a separate conduit or raceway system that is physically isolated from the 480 volt panel. This will ensure compliance with the National Electrical Code and minimize the risk of electrical faults. In addition to the National Electrical Code requirements, it is also important to consider local electrical codes and regulations. Local codes may have additional requirements or restrictions regarding the installation of electrical conductors. It is always best to consult with a qualified electrical inspector or engineer to ensure that the electrical installation is in compliance with all applicable codes and regulations. In summary, National Electrical Code Section 450.13c prohibits running conductors of different systems in the same equipment, enclosure, or raceway without a barrier. National Electrical Code Section 450.13d allows for the installation of conductors of different systems in a common raceway only where separated by a continuous and firmly fixed barrier. The 480 volt panel does not qualify as a suitable barrier between 480 volt conductors and 120/208 volt conductors. Therefore, it would not be code compliant to run the secondary conductors of a 480/208 volt transformer through the 480 volt panel to the 120/208 volt panel. Maintaining separation between electrical systems is crucial for safety, reliability, and ease of maintenance. Always consult with a qualified electrical professional to ensure compliance with all applicable codes and regulations. Firstly, let's discuss the specific requirements of National Electrical Code Section 450.13c. This section explicitly prohibits the mixing of conductors from different electrical systems within the same enclosure or raceway. The key phrase here is different systems. In the context of the question, the 480-volt system and the 120/208-volt system are considered distinct electrical systems due to their different voltage levels. Therefore, the code prohibits running conductors from both systems through the same panel without proper separation. The rationale behind this rule is to prevent potential hazards arising from accidental contact between conductors operating at different voltage levels. Secondly, we need to examine National Electrical Code Section 450.13d. This section provides a conditional exception to the general rule stated in 450.13c. It allows conductors from different systems to share a common raceway, but only if they are separated by a continuous and firmly fixed barrier. The purpose of this barrier is to provide a physical separation between the conductors, minimizing the risk of electrical faults. The code specifies that the barrier must be continuous, meaning it must extend the entire length of the raceway, and firmly fixed, meaning it must be securely attached to the raceway to prevent it from being dislodged. Thirdly, we must assess whether a standard 480-volt panel meets the requirements for a continuous and firmly fixed barrier as defined in National Electrical Code Section 450.13d. In most cases, a standard electrical panel does not meet these requirements. While the panel enclosure itself provides some degree of physical protection, it is not designed to act as a barrier between conductors of different systems. The internal components of the panel, such as busbars, terminals, and wiring, are typically not insulated or arranged in a way that would prevent accidental contact between conductors operating at different voltage levels. Therefore, simply running conductors through the panel enclosure does not satisfy the code requirement for a barrier. Fourthly, let's consider the practical implications of violating National Electrical Code Section 450.13c and 450.13d. Running conductors of different systems through the same enclosure without a proper barrier can create a significant safety hazard. If the insulation on the conductors were to fail, it could result in a short circuit between the 480-volt system and the 120/208-volt system. This could lead to a variety of problems, including overheating, equipment damage, fire, and electrical shock. In addition, it could complicate troubleshooting and maintenance efforts. Fifthly, it's important to note that the interpretation and enforcement of the National Electrical Code can vary depending on local jurisdictions. Some jurisdictions may have more stringent requirements than the National Electrical Code, while others may have specific interpretations of certain code sections. Therefore, it's always advisable to consult with local electrical inspectors or engineers to ensure compliance with all applicable codes and regulations. Sixthly, it is worth mentioning the importance of proper labeling and identification of conductors. The National Electrical Code requires that all conductors be clearly identified as to their voltage and system. This is especially important when conductors from different systems are located in close proximity to each other. Proper labeling helps to prevent accidental contact with energized conductors and ensures that qualified personnel can safely work on the electrical system. Seventhly, let's discuss alternative wiring methods that would be code compliant. Instead of running the 120/208-volt secondary conductors through the 480-volt panel, there are several alternative wiring methods that can be used. One option is to install a separate raceway system for the 120/208-volt conductors. This could involve using a dedicated conduit or cable tray system to route the conductors from the transformer to the 120/208-volt panel. Another option is to use a listed and labeled wiring method that is specifically designed for running conductors of different systems in the same raceway. These wiring methods typically include built-in barriers or other features to ensure proper separation between the conductors. Eighthly, consider the potential for induced voltage or current flow between conductors of different systems that are run in close proximity to each other. Even if the conductors are properly insulated, the electromagnetic fields generated by the 480-volt conductors can induce a voltage or current in the 120/208-volt conductors. This induced voltage or current can cause a variety of problems, including equipment malfunction, nuisance tripping of circuit breakers, and increased energy consumption. To minimize the risk of induced voltage or current flow, it's important to maintain adequate separation between conductors of different systems and to use shielded conductors or raceways where necessary. Ninthly, it's crucial to consider the overall design and layout of the electrical system when determining the best wiring method. Factors such as the distance between the transformer and the 120/208 volt panel, the available space for routing conductors, and the environmental conditions can all influence the choice of wiring method. A well-designed electrical system will minimize the risk of code violations and ensure safe and reliable operation. Tenthly, remember the importance of using qualified personnel to perform electrical work. Electrical work can be dangerous, and it's essential to have the necessary training and experience to perform the work safely and correctly. Always hire licensed electricians or qualified electrical contractors to install or modify electrical systems. 11thly, it is critical to ensure that all electrical equipment used in the installation is properly listed and labeled by a recognized testing laboratory such as Underwriters Laboratories. Listed and labeled equipment has been tested and certified to meet safety standards, and it is more likely to perform safely and reliably. Using non-listed or counterfeit equipment can create a significant safety hazard. 12thly, the design and installation of electrical systems should always be in accordance with the manufacturer's instructions for the equipment being used. The manufacturer's instructions provide detailed information on how to properly install and operate the equipment, and following these instructions is essential for ensuring safe and reliable operation. 13thly, it is important to periodically inspect and maintain electrical systems to identify and correct any potential problems before they lead to more serious issues. Regular inspections can help to detect loose connections, damaged insulation, and other conditions that could create a safety hazard. Maintaining electrical systems in good condition is essential for preventing electrical faults and ensuring the safety of personnel. 14thly, it's crucial to follow proper lockout/tagout procedures when working on or near energized electrical equipment. Lockout/tagout procedures are designed to prevent accidental energization of equipment during maintenance or repair work. Following these procedures can help to protect workers from electrical shock and other hazards. 15thly, it's essential to use appropriate personal protective equipment such as gloves, safety glasses, and insulated tools when working on or near energized electrical equipment. Personal protective equipment can help to reduce the risk of electrical shock and other injuries. 16thly, consider the impact of harmonics on the electrical system. Harmonics are distorted waveforms that can be generated by nonlinear loads such as electronic equipment and variable frequency drives. Harmonics can cause a variety of problems, including overheating of equipment, increased energy consumption, and interference with other electrical devices. To mitigate the effects of harmonics, it's important to use harmonic filters or other mitigation techniques. 17thly, it's important to properly ground and bond all electrical equipment. Grounding provides a path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock. Bonding connects all metal parts of the electrical system together, which helps to equalize voltage and reduce the risk of electrical shock. 18thly, it is critical to adhere to all applicable safety regulations and guidelines when working on or near electrical equipment. Safety regulations and guidelines are designed to protect workers from electrical hazards, and following these regulations is essential for preventing accidents. 19thly, it's crucial to maintain accurate and up-to-date documentation of the electrical system. Documentation should include wiring diagrams, panel schedules, and other information that is necessary for troubleshooting and maintaining the system. Accurate documentation can help to speed up repairs and reduce downtime. 20thly, remember that electricity can be dangerous, and it's important to treat it with respect. Always follow safe work practices and take precautions to prevent electrical accidents. 21stly, it's also important to consider the potential for future expansion or modifications to the electrical system. When designing the system, it's a good idea to provide extra capacity and flexibility to accommodate future needs. This can help to avoid costly and time-consuming upgrades later on. 22ndly, The NEC covers a wide range of other considerations for transformers, including overcurrent protection requirements as outlined in NEC Section 450.3, grounding requirements per NEC Article 250, and specific installation rules for different types of transformers, such as those containing flammable liquids. 23rd, Section 110.3. B of the NEC emphasizes that all equipment must be installed and used according to the instructions included in the listing or labeling. This includes transformers, panels, and all associated wiring. Failure to follow these instructions can result in unsafe installations and code violations. 24th, with respect to wiring methods, Chapter 3 of the NEC provides detailed rules for various wiring methods, such as conduit, cable, and wire types. Depending on the installation environment and the specific requirements, different wiring methods may be appropriate. Ensuring the correct wiring method is chosen and installed properly is essential for safety and code compliance.